and welcome to the first step of our Vyper workshop. We are going throughout this workshop to be building an AI agent that can perform actions on chain, on Polygon, through a Vyper smart contract. So overall, it's going to be a fairly simple, it's just going to be a toy example, a toy project, but it's going to allow us to showcase some interesting features of Vyper. So what the agent is going to do is it's a simple architecture. It's going to fetch some news, some headlines from an RSS feed, and it's going to send those headlines to, well, our actual agent, to an artificial intelligence model. And that agent is going to decide whether, among all of the headlines that it receives, there's something that could be meme worthy, something that's funny or interesting, and that might work well as a meme coin. And so, if there is such a headline, then the agent is going to create a ticker, a name, a little short story introduction to the idea behind the meme coin, the concept, as well as an image. And it's going to deploy it on Polygon. It's going to add liquidity for it, create a trading pool for it on QuickSwap, and then it's going to advertise the coin on social media, on Twitter. Right. And so to do that, we're going to be using modules, which is the way that Vyper does code reuse. So we'll use modules to for our ERC20 tokens. It's going to let us use blueprints, which allows you, blueprint contracts in Vyper allow you to deploy many different instances of the same sort of template contract. Right. So you can deploy the same contract, but with a lot of different, with as many different parameters as you want. So for example, in our case, we use it to deploy the same ERC20 contract, but with a different name and different ticker, different symbol for each instance of the contract. And then finally, we'll be working with Moccasin, which is a brand new framework for Vyper smart contract development, and which will allow us to write tests, but also perform some actions on chain through a Python script. And so it's going to be a great way to demonstrate how easy it is to manage your Vyper smart contract from within a larger Python project, right? Our AI agent project is going to be, we're going to have a bunch of services that fetch the news, that interact with the OpenAI API, and that's all regular Python. And then we're going to have our test suite, which is also going to be with PyTest and also going to be a regular Python. And within all of that, we'll have our Vyper smart contract and the code to interact with them. And so that can all be done within the same Python project. So it's a very sort of unified and very user-friendly developer experience. But before we get into the actual code, we are going to set up our dev environment for Vyper programming. So if you're familiar with blockchain development, maybe you've done a bit of Solidity, of your work, you've worked with Foundry before, you do know that setting up your dev environment can be a little challenging. Um, I like to think that setting up a dev environment with Vyper is actually a lot more straightforward. Right? And so I'll demonstrate this right now. So we are going to start by cloning our project repo. All right, and so that's done. We're going to cd into it. And this is going to assume that you have Python installed on your computer. If you don't, we are going to be using UV as our Python package manager. And UV also lets you do Python version management. So if you do not have Python, you can actually install it uh, through UV. So just install UV, and then this will let you install Python and the version that is actually needed for this project, right? So here, I've actually specified this Python version in our PyProject.toml, right? And so UV automatically is going to use, if not fetch, if it's not installed, the appropriate version of Python. Right, so UV works as like PyEnv, Poetry, Bit, like all together. So it's Python version management, package management, as well as virtual environment management, all in one single tool, which also happens to be extremely fast compared to its competitors. Right. So once you've installed Python and UV and you've seeded into our repo, what we're going to start by doing is create a virtual environment. And so that's fairly easy, UVVN, right? And so the virtual environment is created, and we just got to activate it in our command line to make sure that it works. And next, what we're going to do is install the dependencies of our project. Right, so we're going to do uv pip install dot, and that's going to install all of the dependencies for our Python project. Right, so this is going to install Moccasin for us, for example, right, which is our dev framework. Right, you can see it here. Um, Moccasin is made by Cyfren, which also has a great Vyper course for beginner and intermediate level. And if you haven't checked it out, I highly recommend it. Right, and Moccasin is extremely user friendly and also extremely fast. So this is what we'll be using to help us write our tests and write our smart contracts. And it's not just a dev framework, but it also got a few nifty features. Like here, it's got a wallet manager, so that you don't have to store your private key to your wallet in an environment variable, like a clear in clear. You can here with Moccasin, you can actually encrypt your private key, right, and use Moccasin to decrypt it on the fly to manage it in a secure way. All right, so once you've got Moccasin installed, we have within our Python project, we've got a Moccasin project, right, and that's going to be our smart contract. And those are also going to have dependencies. And so we need to install them. Right, so we run uv run moccasin install, and that's going to install snakemate, which is the dependency that our smart contracts are going to depend on. Right, and snakemate you can think of as a sort of extension to the Vyper standard library, if there's such a thing. Um, or maybe a better way to think about it is if you've ever developed with Solidity, it's kind of like Solidity or the Open Zeppelin contracts, right? It's a suite of contracts, a very common smart contracts that you will need for pretty much any project, right? Any project, you'll probably have an ERC20 token. Right? And so this is going to provide you with a standard, secure implementation of that standard. Right, so we've got an ERC20 package somewhere in there right here. If you want to work with Vault, they've got ERC4626. You've got rights management here, ownership management with Ownable, multi-call, Oracle proof verification, right? So all of those very common patterns in smart contract development, you don't have to write them again from scratch, but you can rely on something that's been uh, very well written and battle tested instead. Right, so this is Snakemate, and this is what we're going to be using for our modules when we write our smart contracts. All right, so we have Moccasin set up, we've got our library set up, and we are almost good to go. One more thing that we do need to do is set up our environment variables here. Right, so there's a .env.example file at the root of the repo. And what you want to do is rename it to .env and then fill out those environment variables. Right, so your Polygon scan token is free to create an account to get an API key. Same thing for Block Scout. OpenAI key, you're actually going to need to subscribe to OpenAI. So if you do want to test out the agent, right, you're going to need to get one of those API keys from OpenAI. You can probably just change the code a little bit and maybe use DeepSeek, which is a lot cheaper, or Anthropic, or maybe a local model, right? That's up to you, but you would have to modify the code a little bit. And then Twitter here, please do not use your actual credentials for this. Um, We're gonna need just create a throwaway account on Twitter just for testing purposes, and then you can use the with a throwaway email, and you can use this for the sake of testing the project, right? But storing your Twitter credentials in clear in a .env file, right, is kind of a recipe for a security disaster. So do not do it with your actual credentials. The reason we do this is um, just to test out the project, and getting an API key for Twitter is pretty complicated. If you do want to have a legit actual agent, you're going to need to apply for that developer API key. For the purpose of our toy example, we're going to just use a Python package that uses Selenium under the hood, sort of a fake browser, to log us in into Twitter and post things on our behalf. All right. So once you've done this, I think you should be good to go. You can run the test. So here, edit configuration, right? So if you're using PyCharm like I am, right, just add your Python interpreter. PyCharm's probably going to find it out from the virtual environment and install it automatically, like it did here. And then you can add a module moccasin test. Right? And here I'm forking the Polygon network to run our tests. And if you've done this and you've set up your environment variables properly, right, you will be able to run the test. Here, I don't have environment variables, so they're going to fail, but normally they should all pass. Um, One last thing that's worth looking into is the moccasin configuration here. So when you initiate a moccasin project, moccasin is going to fill out some of the boilerplate for you, right? Like, where is your .env file? Here, if you add dependencies to your project, right, you would do this with uh, your configuration. Right. So here, this is SnakeMate that we're going to use for our modules. And then I've added a couple of networks, right? So Polygon and Polygon fork. Right? So the fork is going to be a fork of the Polygon mainnet that we're going to use as a testing environment, but right, we're going to interact with the QuickSwap contract to deploy new pools. Right? So we are going to need to uh, fork the network so that we can call this contract and deploy a new pool. So we define this. We give an RPC here. Fork equals true to tell Moccasin that this is going to be a toy example, and so it's going to send whatever default account we use, some gas money, so that we can perform actions on chain on the fork. And then networks.polygon is the actual production network. Right? And here I've specified a default account name. So I've called it account, but you can call it whatever you want. But in order to be able to use it, you need to create that wallet with Moccasin, right? So you would go UV Moccasin, UV run Moccasin wallet, and then Moccasin will take you through the steps to create a wallet, right? So wallet here, you can generate a new one. Um, or you can import one. You can import your private key. I would recommend generating a new one, right? And when you get the address of that new wallet, then you can send a couple tokens to it to pay for gas, because we're going to be deploying contracts and performing some transactions. But Polygon is a very cheap chain, right? So you don't need to send uh, only a couple dollars for gas money should be more than enough. All right. So make sure that when you generate the wallet, right. So the following arguments are required name here. Right. So generate, and then it's going to be account. Right. I already got an account named this. So I'm not going to actually run the command, but if you're creating one, right, call it account, calling whatever you want, but make sure that whatever you named it, just make sure that you update the toml configuration file with it. All right. And then that's it. Your development environment is set up. You do not have to use PyCharm if you're not a fan of it. I'm used to those IDEs, but we've got Vyper support for Visual Studio, which is actually better supported than with PyCharm. Vim, NeoVim, Emacs, whatever you prefer, there is a Vyper plugin for it. All right, so this is the end of our setting up session for our dev environment, and we'll continue on in the next session by writing an ERC20